Next, we will see the time complexity of building a heap from array. So we knew that if we talk about a perfect binary tree, because every perfect binary tree is a complete binary tree as well. If you talk about perfect binary tree, n by 2 nodes are at the last level, n by 4 nodes are at second last, n by 8 node are at third last, and this goes on. We are calling heapify only on the internal nodes and not on the leaf node. If we see it level wise, how many times the heapify can be called both by recursion and iteration. So if we are on second last level, there will be n by 4 elements, and heapify can be called at most once. Why? Because this can go at most one step down. In heapify, every node is replaced by its child if it is not following a property. So in the worst case, these nodes are going only one step down. Okay, so heapify will be called only once on these nodes. In the nodes above this level, there will be n by 8 nodes, and that can go 2 levels down. So heapify can be called at most 2 times, and this goes on till we have the root node, which can go down log n minus 1 times. The height of the tree is log n. There are total n nodes. So log n minus 1 time it can go down. Now this one, I can write this one as n by 2 to the power log 2 n, because a to the power log a b is equals to b. So 2 to the power log 2 n will be equal to n, and we cancel n out, so it will be 1. So this is the total number of times the heapify will be called both by that for loop and recursion as well. So if we find the sum of this, because inside heapify we are only doing constant work, so the number of times the heapify is called will be the time complexity of building the heap from an array. If we see this term is going in GP and this term is going in AP. So this is AGP, arithmetic geometric progression. The common ratio in this is 1 by 2. If we only see GP term, then the common ratio is 1 by 2. So we will multiply S with 1 by 2, so it will become S by 2, and we will shift this one step ahead. So this n by 4 multiplied by 1 by 2 will become n by 8. This n by 8 multiplied by 1 by 2 will become n by 16, and 2 is there with it. So multiply by 2. This n by 16 will become n by 32 into 3, and so on. Here it will become to the power log 2n, and this will be log 2n minus 2. The term before this will be this only. Plus we will multiply this with 1 by 2. So this will become n by 2 into 2 to the power log 2n, and this will be log 2n minus 1. So this will cancel out. Okay, and let's see this. What I will do now, I will subtract these terms. So this will become s by 2. S minus s by 2 is s by 2. This will be n by 4 plus 2 into n by 8 minus n by 8 is n by 8 plus n by 16 plus n by 32, and so on. This term will become n by 2 to the power log 2n. Minus this will remain log 2n minus 1 by 2. Now I'll multiply this 2 on this side. So s equals to n by 2 plus n by 4 plus n by 8 plus, and so on. This will be n by 2 to the power log 2n minus 1. Everyone's power is reduced to 1. This was 2 to the power 2, it becomes 2 to the power 1. This was 2 to the power 3, this becomes 2 to the power 2. So this power will also be reduced by 1, right? Or you can see in this way that this 2 will get multiplied here, and the base is same, 2 and 2, 2 to the power 1 and 2 to the power log, and base is same when they are in divide, then we subtract the power. And 2 will cancel this 2 out. So this will be log 2n. This minus will go inside. So this will be plus 1. If you take n common here, this will become 1 by 2 plus 1 by 4 plus 1 by 8 plus, and so on, 1 by 2 to the power log 2n minus 1 minus log 2n plus 1. Now we'll see only this GP. Everything remains the same. This is like, let's say this is equation number 1. We are only seeing the GP. GP is 1 by 2 plus 1 by 4 plus 1 by 8 plus up to 1 by 2 to the power log 2n minus 1. The first term is 1 by 2. The common ratio is 1 by 2. The sum of GP is, because r is less than 1. When r is less than 1, the sum of GP is 1 minus r to the power number of terms divided by 1 minus r. What will be the number of terms? 2 to the power 1, 2 to the power 2, 2 to the power 3. From 2 to the power 1 to 2 to the power log n minus 1, number of terms will be log n minus 1. So a will be 1 by 2, 1 minus 1 by 2 to the power log n minus 1 upon 1 minus 1 by 2. This will cancel out. 1 minus 1 by 2 is 1 by 2. So this will cancel out. And we can write this as 1 minus 1 by 2 to the power log 2n minus 1. Now the power is in subtraction, so we can move this to division. So this will be 1 by 2 to the power 2 by 2 to the power log 2n, and this will be equals to n as we have seen earlier. So this will be 1 minus 2 by n. If we see the LCM, this will be n minus 2 by n. So the sum of this GP is n minus 2 by n. So if we put it here, it will be n into n minus 2 by n minus log 2n plus 1. This n will cancel out. So this will be n minus 2 minus log 2n plus 1. This will be n minus log 2n minus 1. So this will be the number of times the heapify will get called, and if we write in asymptotic notation, it will be big O of n. So this will be the time complexity of building a heap. Okay, thank you.